Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to give you a quick overview of what the ProteusDS Oceanographic toolset can do in the mooring analysis and design process for you. So what we're going to do is go through some of the sample files that we have, and if you go to our website, ProteusDS.com, and you go to Learn, and then Documentation, you'll find a collection of sample oceanographic mooring files that you can download here. It's a zip file, so make sure you unzip it before you work with it. And I've got it here all ready to go on my desktop. So there's a number of projects you can look at with mooring files. And we're going to look at the Del Mar Oceanographic Wire Walker sample mooring. So this is a template mooring, and all that means is that it doesn't have a specific location in mind, but you can play with it and adapt it and use it for your own projects. So when we double click on this file, it opens up in Oceanographic Designer. Now, Oceanographic Designer is an excellent place to start the design process. And you use it to, in conjunction with our official parts library, to put together a detailed oceanographic mooring. You add either lines or assemblies. And then in the assemblies, you have an option for, in the subassembly window here, adding things like connectors, instruments, syntactic foam floats, things like that. Now, you can see here, just as an example, we've got one assembly here called Connector Assembly A, and then if we click on the plus window here, we can add any number of other connectors that are in the parts library. If we just look at, for example, this entry, Safety Anchor Shackle, you can see all the parameters here for that shackle and the URL from where the spec sheet is from. So it's just loading up on the Crosby website here. You can find the spec sheet and all the parameters that we've got for it there. If you like, you can see the units in different, and just do the unit conversion directly automatically if you want to look at this in millimeters, or the working load limit in pounds instead. So there's that automatic conversion, which is really handy. There's a quick search here as well for finding things that you want to add from the parts library. So, and here's an example of wire rope, and you can change the length just by clicking on it in here and adjusting the numbers. So Oceanographic Designer is great because it does a lot of bookkeeping for you. It keeps track of the total dry weight, the total wet weight of all the components in the system. You get estimates of the estimated depth of the components in there, as long as the tension is not is significant, it's not close to zero. And the total mooring length, the scope for the water depth, and things like that. You do get a basic estimate of top tension and anchor tension as well, which is super helpful for that initial design stage. So we can put in the current profile. You can actually put more than one current profile in here, and this is fairly nominal, but it's just a starting point for doing the static analysis and later doing the dynamic analysis in Simulation Toolbox, which you would use the export here to static or dynamic. And I have some sample results to show for that. So what we'll do is we'll jump over to some results here in Wave. So this is Simulation Toolbox, and we've already got some results completed in 5 meter significant wave height and 9-second peak period. So if we just load the results here. Now, I'm not going to load the whole data set, but what I'll do is we'll just look at a section of it, 50 seconds. And this is our nice 3D rendered view of the system in waves. What we'll typically do is we'll go to Engineering View. Just make that a little bit bigger. And you get a nice big perspective on what's happening here. We can plot the tension as well and just play that back. So again, 5 meter significant wave height. You can see the buoys tracking waves nicely. For wave actuated profiler systems, you can see the down weight here. It's keeping the system nice and vertical. That's going to mean we're getting nice profiles, and we've got a bit of a false bottom effect here with the trawl floats and so on. So keep an eye on what's going and just make sure you get a realistic look at what's happening. The other thing you can do is automatically post-process the results and verify the loads and motions of the system, and I'll show you that with the report tool. So what we can do is just pause this for now and go over to the Oceanographic Report tool. And what we'll do is, often what I like to do is highlight a few key components that I'm interested in for the summary page. So we have the surface buoy, for example, maybe the down weight as well. And I usually recommend skipping the first 10 seconds of the simulation just to ignore any transient effects that might be artificial, and we'll go generate. And what's nice about this is it makes a nicely formatted Excel file for you, in which you can see, by the way, you can change the units after the spreadsheet's generated, change it to pounds, and then a lot of the units will change through the whole system in the spreadsheet automatically for you. But it gives you, it highlights if there's any components that are below minimum allowable safety factor. You can see that we have the surface buoy and the down weight here. It's on the summary sheet here where it's tracking the maximum load at and when does it happen in the simulation. So we can go back to PostPDS and check it out for a closer look. There's a submergence probe on the surface buoy, so you can keep an eye on submergence if there's any, and what kind of rate of occurrence that's happening at there. And anything you want to take a closer look at, there's all the line components have their loads, and if there's a minimum braking load, you get a safety factor for those components. Obviously pretty high safety factors here, which is good to see, and loads and all the connectors and things like that. But you get a nice summary and checking on the any depth ratings, pressure ratings, and things like that if you're exceeding depth ratings, as well as the working load limits and minimum braking loads. So this just meant as a quick overview to show you all the things you can do as part of a systematic design process with ProteusDS. Thanks for watching.